Why are roots important for understanding polynomial behavior? Imagine trying to understand how a roller coaster moves without knowing where it starts, stops, or changes direction. In algebra, roots are like those key points that tell us where a polynomial crosses or touches the x-axis. They are the solutions to the equation where the polynomial equals 0. Knowing these roots helps us see the shape of the graph and how the function behaves. When you look at a graph of a polynomial, the roots are the points where the graph hits the x-axis. These points are important because they show where the output of the function is 0. If you want to sketch the graph, finding the roots gives you a clear idea of where the graph crosses the x-axis. This helps you understand where the function changes from positive to negative or vice versa. Roots are also connected to the factors of the polynomial. For example, if x equals a certain number is a root, then the polynomial can be written as a product that includes a factor like x minus that number. This makes solving equations easier because you can break down complex polynomials into smaller, simpler parts. Factoring is a powerful tool that helps you solve equations and analyze how the polynomial behaves. The degree of the polynomial, which is the highest power of the variable, tells us how many roots the polynomial can have. For example, a quadratic polynomial, which has the highest power of 2, can have up to 2 real roots. A cubic polynomial can have up to 3 real roots. This helps set expectations about how many times the graph might cross the x-axis. Another important aspect is the multiplicity of roots. If a root repeats more than once, it affects how the graph looks near that point. If a root has an odd multiplicity, the graph crosses the x-axis at that point. If it has an even multiplicity, the graph touches the x-axis and turns around without crossing. This detail helps you understand the shape of the graph at each root. Understanding roots also helps in real-world situations. For example, in business, roots can show break-even points where profit turns into loss. In physics, roots can indicate when a physical system changes state or behavior. In summary, roots are vital because they show where the polynomial equals 0, connect to factors, determine the number of x-intercepts, and influence the shape of the graph at those points. Learning about roots makes it easier to analyze, graph, and solve polynomial equations, giving you a solid foundation for exploring more advanced algebra topics.